So I'm going to put 12-6. I'll put part 2. And that's how I put it on the videos if you want to look at it online. It's rational expressions with unlike denominators, part 2. The return of the denominator. Okay, let's look at example 3, and this is going to help us to know why did I even spend so much time talking about LCM. Okay, example number 3, it says find 7 over 3m plus 5 over 6m squared. So 7 over 3m plus 5 over 6m squared. Okay, can I add these two fractions just the way they are? No. So yesterday what I had you do, and last night or this morning, I wanted you to get the LCD. What does LCD stand for again? Least common denominator, which means the LCM of the two denominators. Okay, what is the LCD of these two rational expressions? 6m squared. That's correct. And hopefully you guys can see that. If you didn't know, you can use your prime factorization. I'm going to make two fractions that have that 6m squared, the LCD, as their denominator. Okay, so I want 6m squared as the denominator of both of these fractions. And again, they were being added. Okay. I want to rewrite this problem in a way that makes it easier or able to work it out with addition. So let me ask this question. What did I multiply 3m by to get 6m squared? 2m. So this is, I'm going to show you what the thought process is, and then you could do it a little bit different on your homework. I multiplied 3m, you guys said, by 2m. So what should I multiply 7 by? 2m. Now, does anyone know why I would have to multiply the numerator and denominator by the same thing? Hayes? Yeah, because what's 2m over 2m? 1. So what's 7 over 3m times 1? It's itself. What property is that? Identity. I did not change the identity. I changed the way the clothing that was on that person, but not the person itself. Okay, so what's 2m times 7? 14m. So, can I ask this question? 7 over 3m and 14m over 6m squared, are they different in value or the same in value? Same. But, now that I have this fraction, can I add it with the other one? Yes. What did I multiply the second one by if you multiply it by anything? It's just 1 over 1. That's how I get my 5 over 6m squared. So that one you didn't have to change, right? Can I add these two fractions just the way they are? Yep, because they have the common denominator. So what you do is you add the numerators together, and you should get 14m plus 5 over the common denominator, 6m squared. That is your answer, unless you can simplify it. What about the 14 and 6? I mean the m's. Okay, nothing can cancel here because this right here is a sum, and it can't be factored anymore, so it can't be canceled with anything down there. That's your answer. Yes, sir.
Technically, aren't the m's, both the m's factors? Because 14 is being multiplied by it.
Yeah, so these, you can see this one's a factor of 6 and itself, and then 14 and m are both factors, but you can think of it when this monomial is tied with a plus or minus sign, you got to think of this all together. Like it's a unit. Either cancel it all out, or you can't cancel it at all, which is a good point there. Okay, that's your answer for example 3. You know what I basically made you do on your homework? I basically made you take each problem, such as example 3, and get me that LCD, and then what you're going to do on your homework is just use that LCD to figure out what the numerator should change to, and then add or subtract. So I basically made you do half the problems of the homework, so now all you have to do is the other half. Okay, I want you to write this down because maybe today it seems pretty easy, but maybe tomorrow or next week, especially on Friday of next week. What a great question.
Test. It says
Test.
subject.
It's not gonna, I'll put it up tomorrow so you don't think it's tomorrow, which hopefully you wouldn't think that anyway if you're paying attention at all in class. But it'll be next Friday, yeah. It'll be next Friday. All right, steps to add or subtract these rational expressions. First step, find the LCD. Find the LCD of the two fractions or three fractions, usually two, which means you have to factor first. So I'm putting this for your own benefit. So factor, find the LCD. All right, you got the LCD, great. Number two is the most complicated step. Change each fraction to have the LCD, and then I tell you how to do that by multiplying. Bless you. I know, it's exciting. By multiplying, and I put here by a form of 1.
When you say factor first, you mean like when you see the problem, like before anything you factor?
You should factor, because when you factor the numerator and denominator, then you know, oh, that's the LCD. But some of them you could figure it out just by looking at it. So if you don't get it at first, factor it, then you should get it. Change each fraction to have the LCD by multiplying by a form of 1. Okay, you're like, a form of 1? What are you talking about? What was the form of 1 that I multiplied by? 2m over 2m. So that it's unique to every problem, 2m over 2m. What's the form of 1 that I multiplied here by? 1 over 1. So you didn't really have to multiply by 1, but it's technically there. Okay, anyone need that? Okay, just a couple more steps, a little bit simpler here. Number 3, add or subtract the numerators and keep the same denominator. And as I'm writing this down, now that I'm saying it out loud, writing it down, this is what I would tell students to do when adding and subtracting numerical fractions. You do the same things here. And then last one, simplify. And I put if possible. Sometimes it's not possible, so you're done. But if it is, simplify it. Always make it as simple as you can. Okay, so those are the 4 steps. You guys okay with that? Keep writing it if you need it, and then we'll work out a couple more problems. I'm so tempted. Do you guys notice, maybe by now, after 2 years of having me almost, I sometimes give problems as examples that are really, really hard, or I make you guys do really, really hard problems, but do I tend to give those for the test or quiz? Like the really, really hard problems. Not always. I give you some medium and some tough ones, but not the really, really hard ones. Like, I'm giving you those because you're going to see those again in Algebra 2, and in that case, you know what's going to happen? Those are the really easy problems, and then you get harder problems than that. So you'll be ready for that. Okay, guys good with the 4 steps? 4 steps to a successful math lesson. Okay, and you got that for free. Let's look at number 9 on page 687. 687, number 9. It says find each sum or difference. So I'm just going to write the problem down so we can all see it. All right. I want to find the LCD. And in this case, I don't think factoring is necessary because I think you can see what the LCD is. What is the LCD, Wyatt? I think you're...
15 m squared, but you...
Gotcha. Okay, so I just wanted the LCD. Good. So 15m squared, 15m squared. So yeah, you're thinking ahead, and that's fine. So I want to have both fractions to have a denominator of 15m squared. Okay. What did you have to multiply? So in step number 2, change each fraction so that they have that denominator. Did I have to change the first fraction? No, it already had that denominator, so you just leave it alone. But what do I multiply the second denominator by? 3m
3m.
over 3m. Because I want to multiply by a form of 1. So what's 3 times 3m? 9m. What's 5m times 3m? 15m squared. So that's how I got it. It doesn't just magically happen, boom, you got it. You have to use properties. And identity property, is that pretty basic?
Yes.
Yeah, remember, do you guys remember when I gave it to you, maybe 7th grade? Maybe you're thinking, okay. Okay, the identity property is used in very complicated expressions, and it will be even more complicated in one of our last chapters this year. So we'll still use it. Okay, can I add these up the way they are? Triggered, okay.
Oh,
Go ahead.
I got 9m plus 7. No, come on, Mark, you messed up.
What do I think of that?
Are you supposed to put like the variable first? Or
You can.
the one with the
You
variable?
can. You can do it. So if you put 9m plus 7, I'm good because of what property?
Oh, right, but
Yeah, and there's nothing saying write it descending order or anything like that. So you're good. Okay. Let's go to example number 4a. Example 4a. S over S plus 3 plus 3 over S minus 4. Do you guys remember we had to get the LCD of a problem like this? So I'm looking at the denominators thinking, I don't know what the LCD is. I don't even know what the factors are. Or do you? So I look at this denominator. Can I factor it anymore? Nope. I can't factor that anymore. So you're done factoring it. Does anyone know what the LCD of those two?
oh, I understand that.
S plus 12.
Oh, okay. I think, yeah, it's this S plus 3 times S minus 4. That's it. That's all it is. It's those two binomials multiplied together. So S plus 3 times S minus 4. So I alluded to this, but you're going to use that identity property again. And it is going to look a little bit strange, but it's okay because it happens. All right, listen carefully. The first fraction. What did I multiply this denominator by to get this new denominator? Okay, I'm going to multiply the numerator by S minus 4 and the denominator by S minus 4. Is that 1? Yeah, it's still 1. Okay. So what is S minus 4 times S? And on the numerator, multiply it out. So what's this right here? Yeah, S times S, S squared. S times negative 4, negative 4S.
Oh, you want to start like that. Not
In the
like
numerator.
S times S.
Good, yes.
Okay.
The denominator, you can keep them as factors. The numerator, because you're going to want to combine like terms, you want to multiply it out.
Oh, right, okay.
What did I multiply the second fraction to get a denominator of this? I multiplied it by S plus 3 over S plus 3. Because that's a form of 1, right? Okay, so you see I got the denominator. So it's 3 times S plus 3. 3S plus 9. Whew. Man. And we'll do it again, so that'll help us out. Okay, now we did step number 2. Number 3 says to add or subtract the numerators and keep the same denominator. Okay, so this is how I do it. Are there any like terms to S squared? No, so S squared, you stay the same. Any like terms to negative 4S? Yes. 3S, so what's negative 4S plus 3S? Negative S, or negative 1S. Is there any like term to 9? No. So you could say like 0 plus 9, This is positive 9. Oh. This is strange and weird. It is. It's harder. It's more complicated because the expressions are more complicated. And what was the denominator? Yeah, just say s plus 3 times s minus 4. What was step number 4?
Simplify if possible.
If possible. So, listen. This is a trinomial. Can it technically be factored a lot of times? So just think. Are there any two factors of 9 that add up to be negative 1? So think. 3 times 3, 9 times 1.
Yeah.
Nope.
What I have a question. Could it be
It could be a difference of squares if there's only two terms. So like a trinomial won't be a difference of squares. Or a perfect square trinomial. Yeah, and this is a perfect square. That's a perfect square. Is this the product of that square root and that square root times negative 2? It's too small. Yeah. Good. Good. Actually, it's good that you even brought that up because we haven't talked about that for a while. Good. That's your answer. Is it complicated? I think it is. I'll do another one again. No, I'm not going look, here's my example B. Do you guys want to look at it real quick?
Yeah.
This is my example B.
Oh,
Swivl. Here's example B. So you can. This is online only here, where you can see example B, 4B. It's complicated. I'm not going to make you do that one.
Online exclusive.
Online exclusive, yeah. With your subscription to my channel. And a small donation that does not come below a certain amount that you'll see online. Check it out. Check it out. Please, check it out now. Okay, let's do another one together. Make sure we get it. Let's go to page 687. And I want you to add number 10. Number 10 there. Yeah, we haven't done that. So we'll do this one together, or you can do it on your own if you're comfortable with it. All right, step 1, you have to find the LCD. So factor, if possible. Can I factor x plus 3 anymore? No. X minus 2 anymore? No. So now I can already find my LCD. Does anyone know what the LCD is? Benson? X plus 3 times x minus 2. That's correct. So I want both denominators to be that, because then it'll be common. Okay. Second step. Change each fraction to have the LCD as their denominator by multiplying by a form of 1. So does anyone know what I had to multiply x plus 3 by to get x plus 3 times x minus 2? So if I had to multiply this by x minus 2, what do I have to multiply the top by? The same thing. Yes, sir.
I just think of it as like an x. Like you put an x where the plus sign is, and then you just, yeah. Like 2 times, yeah.
Good.
You know what? Yeah.
That's a great thought. No, you can explain it to me later. Sorry, I'm blanking out. It's me, not you. Okay. 2 times x minus 2 is 2x minus 4. Minus 4. That's your first fraction. The second fraction, what did I have to multiply x minus 2 by to get x plus 3 times x plus 3? Yep. X plus 3. And therefore I have to multiply the numerator by the same thing. So this is my work. All right, what's 3 times x plus 3? 3x plus 9. Very good. All right, now I can add this complicated fraction. So I look at the numerators. I'm like, okay, do I have like terms? Yeah, right here. 2x and 3x. What's 2x plus 3x?
5x.
5x. What's negative 4 plus 9?
5x. Or 5, sorry.
Good, plus 5. And then the common denominator was x plus 3 times x minus 2.
Do you have to simplify the above?
Okay, so now looking at the top, I will factor this if I either know or think that I might cancel out one of these factors. But think, what would factor out? A 5 would come out. You'd be left with x plus 1. So would anything cancel? Nope. So you're done with that. What a good question. This homework assignment, no. All right. Let's see. Katie, give me one excluded value. Quiet. One excluded value. Excluded value. What's that? It's on your test on Friday, so. Excluded value. What can one... So I'll give Katie some time here. X cannot equal... X cannot equal negative 3 is one of them. Vivian, the second excluded value. Okay, I'm not putting excluded values as your homework, but you do know how to find it, hopefully. X cannot equal negative 3, X cannot equal positive 2. Very good. Yes, sir?
So why can't there be an excluded value in the numerator?
Yeah, because in any fraction, if you made this equal 0, you would end up with 0 over some number, let's just say x, which is worth 0. But if you made the denominator equal 0, and let's just say you're left with x, this is not worth anything. It's undefined. Yeah, we don't know what that's worth, so we don't want it.
That means there's actually a number on the first.
Yes. There's actual value with 0, and there's no value with something over 0.
Is that an example of an imaginary number?
No, it's not even imaginary. Like, I don't know it.
I don't think imaginary numbers exist.
They do, and here's a proof. Ready, guys? This is what I want you to do. So the question was, or the statement was, I don't think imaginary numbers exist. All right, ready? Clear your mind. Stop thinking of that. Stop thinking of that. Riley, enough? Out of your mind. Clear it up. Okay. Think of the first number that comes to your mind. Boom.
14.
Okay, sorry. Think. So don't say. Let's start this out. Clear that mind. Erase it. Do whatever the whiteboard does. Click it. Okay, it's gone. First number, think of it.
22.
No, think of it.
Oh my.
Let's try this one more time. Let's see if you guys can get it. You guys think you can get it? Think of it. Don't say it. All right, ready? Clear it out. Erase it. Chalkboard. Get that powder off. Get the chalk. What's the first number go?
Oh my goodness.
Okay. For most of you, you thought of a number. Right? You thought of some number, whatever it was. Or maybe many numbers. You were weird like that. That's an imaginary number.
What?
No. I'm just kidding. I'm just, no. That's not maybe what you were thinking.
I still don't think they exist. I would still like.
Oh, they exist.
Yeah.
Okay, your homework tonight is numbers 17 to 31 odd.
Wait a minute.
What?
That was last night's homework.
Uh-oh.
Taxi, Kyra.
Oops. I'm getting older. I think that's it. This one. I am not okay?
Are you okay?
Okay, listen carefully. So on number 17, here's the problem. And I'll put it right here. X over 7. Yes, I know what you guys did, which is good. Minus 2x over 9. Do you guys remember how I made you get the LCD? Okay, the reason I had you get the LCD is because that's your first step. So I already know, what did you guys get for 17? That's your denominator when you're working this one out. So now all you have to do is find out, all right, what did I multiply 7 by to get 63? 9. So I should multiply the top by 9, which is now 9x. what did I multiply the second denominator by to get 63? So I should multiply this by 7 over 7, which gives me 14x.
So the last night's homework actually helped us build up to the
Please
test.
ask questions. We're doing it on the same paper.
Do it on the same paper. So you keep it, you can write it, and if it isn't, just staple it if you didn't.
What if we got the LCD wrong last night?
That's why we graded it. And if you got it wrong, you can ask me what the correct answer is, or you can ask each other if you didn't get it. That's okay. Sorry? Okay, so the answer would be negative 5x over 63. That would be your sum or difference, however you want to look at it, of number 17. All right, I'll give you a few more minutes to work on that. And then we'll go over that tougher problem